Hello everyone. Today I will show the solutions to the Prairie Math League High School Round 126 problems 5 and 6. For problem number 5, we have a bunch of consecutive integers and we remove 4 of them, or at least 3 of them are consecutive. And all these integers must be greater than 100 and distinct from each other. We see that the average of the remaining must be 89.5625, and we need to find the number of possible values of s. So first we get bounds on n, which is, n. If n is less than 179, then we can't have an average that would be at least 89.5625 after removing the 4 integers. To clarify this, this is the thing that we could remove to least affect the average. However, this for n is less than 179, these 4 numbers don't work. So n is greater than or equal to 179. We have a similar reasoning for below. If n is greater than 183, then even if we remove n minus 1, n minus 2, and n minus 3, we're still going to have a final average of more than 89.5625. So n is less than or equal to 183. Now we have an average remaining over n minus 4 numbers because we started with n numbers and removed 4 of them. Hence, the remaining sum must be an integer. So we test each of the values from 179 to 183, and in fact, only 180 works. Then now we use a formula. We now find the sum of P, Q, and R, and S. So this is the original average. The original sum, and then we subtract 4 of these and then divide by n minus 4. And solving this, we see that P plus R plus S is equal to 527. We now use the principle of inclusion and exclusion, which I mentioned before in the previous video. But to recap, this is basically saying that if we know the number of elements here, we know the number of elements here, and we know the number of elements here, then we can find the area of this entire thing, the union. So now we considered the two cases as PQR consecutive or QRS consecutive. So if PQ, R, and S are consecutive, for instance, consider this is consecutive, and so on, then the positive value of S is 134 to 179, skipping multiples, every multiple of 3, which gives us 16 values. And we can do a similar thing for the other case, and we get only 10 values here. But the thing is that we overcounted these. So these are the things that we overcounted, because here we start at 134, skip multiples of 3, and here we also start at 1 over 34, although we go every only like 1, but we only go up to 143. So we're basically finding the multiples we're basically finding the numbers that are congruent to 134 mod 3 that are in this bound, which gives us 4 values that we overcounted, and by pi we just, this plus this minus this is 22, so our answer is E. Alright, for problem number 6, we're given a triangle inside a circle, such that the circle has radius 1 and area 1 over 4. The triangle has area 1 over 4. So, yeah, we're given 2 expressions and we need to find a relation relating them. Or rather, an inequality relating these. So to start, we're going to use the circumcircle area formula, which states that if there's a triangle inside a circumcircle, or a circle, just any circle, then the area of the triangle is ABC over 4R, where ABC are the side lengths and R is the radius. And here, this is equal to 1 over 4 because the area is 1 over 4. Hence, ABC is equal to 1. Now this means that we can multiply s by square root of abc and t by abc because both of these are equal to 1 and the multiplication won't change anything. So s is equal to this expression and t equals this expression. Now the point in multiplying these is because we're going to use something called homogenization, which basically means that we want to set two sides with this equal to the same degree so that we can apply some other inequalities. So here, both of these have degree 2. So now we can note that by AMGM we have 3 inequalities. AMGM is arithmetic mean, geometric mean, and basically states that if we have two numbers and both of them are non-negative, then x plus y over 2 is greater than or equal to xy. We can use this with x equals AB and y equals AC. And we can apply this again with AB and BC, AC and BC. Now, the thing about AMGM is that equality holds when x is equal to y. In this case, equality cannot hold for all three of these, because if it did, then we would have A equals B equals C, which would mean that either the area is greater than 1 over 4 or the radius is less than 1, or both. Hence, at least one of these inequalities is strict, which means at least one of these is actually like this. And so the final expression that we get after we sum all three inequalities will be strict. And notice this is equal to t, and this is equal to s. Hence t is greater than s, which gives us answer choice C. Thank you to Stephen for explaining to me the solution for this problem. And thank you for watching.